Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences Bioscience Talks, which is a forum for integrating the life sciences. For today's episode, I'm joined by Peter Gleick, who's the co-founder and a senior fellow at the Pacific Institute in Oakland, California, author of the new book, The 3 Ages of Water, and a member of the National Academy of Sciences. He joined me to talk about a number of water-related topics, starting with a recent piece that he wrote in the Kyiv Independent about the recent destruction of the Kakhovka Dam on the Dnieper River and the ensuing human and ecological tragedies. We also talked about his new book, The 3 Ages of Water, which tells the fascinating story of human history and the way that it's always been deeply intertwined with the history of water on Earth. It's a captivating book that I really enjoyed quite a bit, and I'll include a link in the show notes for listeners who'd like to learn more. But for now, let's go to the interview. Thank you very much for joining me today.
I'm delighted to be here. Thank you for having me.
Okay, I thought we might get started by chatting about the reason I originally emailed you, which was a piece that you wrote for the Kyiv Independent. And I was hoping you could just tell me a little bit about that piece and sort of, the thinking behind it.
Sure. So I've been working for a long time on the issue of conflict over water, violence associated with water resources. Water is a trigger of conflict. Water is a casualty. Water systems as weapons used during conflicts. And maintain a database of such events going back many thousands of years, in fact. But the destruction of the Kakhovka Dam in the Ukraine, in the new Russia-Ukraine war, is outstanding is the wrong word, sort of a stunning example of the use of violence against water and water infrastructure. The Kakhovka Dam is one of the largest dams in Europe, was one of the largest dams in Europe. The reservoir behind it was one of the most important reservoirs in Europe. And its destruction, we believe by the Russians, has enormous implications for a whole range of things, for the ecology of the region, of course, for the humans who live downstream and the communities and the infrastructure and the cities and towns that are downstream, but also just for the entire idea that such civilian infrastructure should be considered viable targets during warfare, which of course is a violation of international law, I believe. So I wrote this piece for the Kyiv Independent to talk about all those issues. It's a complicated set of issues, but I think it's going to go down as a dark day in history.
Yeah, and I mean, one of the things that shocked me in reading your piece was the volume of water that was released, when this dam was destroyed. I think it was 18 cubic kilometers, equivalent to the entire flow for a year of the Colorado River.
Yes, that's right. 18 or maybe 19 cubic kilometers of water were stored in the reservoir behind the dam. Again, one of the largest reservoirs in the world, in Europe. Many actually much larger than the average flow of the Colorado now, which is probably maybe 14 or 15 cubic kilometers a year. A huge ecological catastrophe, but also a catastrophe for water supply, for water quality, for a whole range of things.
Yeah, it sounds like an enormous step backwards for the people who are living in that region, and indeed for the ecology of the region as well.
Yes, that's right. And I would argue an enormous step backward for the international community, which in theory protects us against these kinds of acts. There are international laws of war that say civilian infrastructure, even in wartime, is supposed to be protected. And yet clearly we've seen intentional gross violations of protection of energy and water infrastructure during the recent conflict.
And from an ecological standpoint, what types of effects do we see when something like this happens? I know you mentioned that millions of fish were killed. Yeah,
so there are short-term consequences and there are long-term consequences. In the short run, of course, the complete loss of water in the reservoir led to the deaths of probably millions of fish in the reservoir. The massive outflow of water from the reservoir also included a massive outflow of sediment that had built up behind the reservoir and an outflow of the contaminants that sediment held, including radioactive contaminants from the Chernobyl accident years and years ago. Industrial and agricultural pollutants were released, including very large quantities of nitrates and phosphates. We actually saw in the very short run very severe algal bloom in the Black Sea when those nutrients washed down the river into the Black Sea. There was a big algal bloom. I think it's faded a little bit now, but But the long-term consequences are likely to include all sorts of pollution events along in the region, mobilization of heavy metals, mobilization of agricultural chemicals, changes in the ecosystems themselves and the biodiversity of the region.
Yeah, I mean, these are just enormous effects that one of the things that I think is, a theme that's repeated in your book is, a lot of times these catastrophes take much, much longer to ameliorate than they take to undertake. So a relatively short-term, disaster results in very long-term effects.
Yes, that's right. So, I did write about this in The Three Ages of Water, when I talk about one of the crises that faces us is the consequences for the environment and ecology of our water decisions and our water institutions and our water technologies. We've built massive amounts of water infrastructure around the world over the last couple of centuries to provide the benefits that we want from water: the hydroelectricity, the water supply, the wastewater treatment, the flood protection, the drought protection. But that infrastructure brought more than just benefits. It brought unintended consequences. And among the most significant unintended consequences were consequences for our ecosystems. We built a lot of big dams when we didn't know about the consequences of destroying these river systems, or we didn't care about the consequences. And now we're suffering the consequences: the loss of wetlands, the loss of free-flowing rivers, the impacts on fisheries, the impacts on migratory birds, the whole range of ecological consequences for aquatic systems that now we understand were a consequence of our decisions about how we built our water systems.
Yeah, absolutely. And because we're going to be talking about the book, I think it probably makes a little bit of sense right now to step back and, talk about those three ages of water. Very broadly speaking, what were they, and, what sorts of things were going on in each of them, or will be going on in the third?
So the book is really the human history of water, going back literally to the Big Bang. But I talk about the first age of water being the time when, from the creation of Earth and the formation of the water resources that the planet has, up through really the first empires, the first efforts to manipulate water, the first agriculture, and the first intentional irrigation, the first efforts to build dams or aqueducts, the first water laws, and the first war over water, again, about 4,500 years ago in ancient Mesopotamia. And that's the first age of water, which ended when populations really started to outgrow our ability to just take the water where we found it and where we needed it, and dispose of our wastes where we wanted. And the second age of water, which is our age, is the period of time when we developed the science and the technology and the biology and the chemistry to, first of all, understand what water resources were and what water-related diseases really were, and develop the technology and the infrastructure to provide the benefits of a modern society. And that's the benefits that the second age of water provided us. And as we've talked a little bit about already, the unintended consequences of those actions. And I argue that the second age of water is ending now, and that the third age of water, which is beginning, has the opportunity, and I actually argue the likelihood, of being a positive, successful, sustainable future. If we only are smart enough to take the actions that we know we can take, to scale up the solutions that we know work, to move toward along this path to a positive third age of water. And I describe that third age and those successful examples in the book.
Yeah, and I look forward to talking about those. Because we began with conflict, why don't we jump back and talk a little bit about, that first water war? Because, one of the things that struck me in reading the book was that so many of the themes that we, go back and see from very, very long ago, thousands of years, are still happening today in a sense. There's a resonance with the things that we're dealing with right now. What was that first water conflict about?
Yeah, that's a great point. A lot of the experiences literally over millennia that we've had around water are still experiences we're having. The first water war that we know of was around 2400 BC between the Sumerian states in ancient Mesopotamia, between the Tigris and the Euphrates rivers, the Sumerian states of Umma and Lagash. And it was a conflict over irrigation water and access to water for fertile agricultural lands between these two city-states. It was actually a conflict that went on for 100 years, over multiple generations, fighting over who controlled the irrigation canals, bringing water from the Tigris and the Euphrates rivers, and who controlled the rich agricultural lands. And we know about this war because it was literally, the history of it was literally carved in stone.
Right.
And archaeologists have uncovered the evidence of the conflict and the written histories of the conflict in the stone monuments that are now in the Louvre. You can go see them in the Louvre in Paris and in France, that talk about the 100-year war between Umma and Lagash.
And they were essentially just, fighting over access to the limited water resources for agricultural purposes.
Yes, that's right. So at the time, in ancient Mesopotamia, in Sumeria and Akkadian and Babylonia, those empires were supported by the ability to grow enough food for their empires, and that required irrigation. Then as now, the region of ancient Mesopotamia, the area that is now Iraq and southern Iraq and part of Iran, was very hot and very dry. And successful agriculture was really only possible with intentional irrigation from the reliable flows of water in the Tigris and the Euphrates rivers. And control of that water meant control of food, and control of food meant the success or failure of these great early empires.
Yeah, and one of the things that struck me in reading the first part of that book was the absolute importance of water in shaping, the way that humans migrated, the way that we disperse throughout the world, and things like that. It seems as though water is interlinked with our own history constantly, and sort of everywhere one looks.
Yeah, well, of course, that's the idea of the book, that the history of humanity is really the history of water and our interactions with water and our ability to understand and manipulate the hydrologic cycle of the planet. Without water, even today, 80% of the water we use goes to grow the food we need. It's a critical part of our economies. Water is necessary for all of the things we choose to do. And the earliest empires in the First Age, ancient Mesopotamia, but also the Indus Valley empires and the great empires in China, all depended on reliable water supplies. They all were founded originally alongside rivers that provided reliable water: the Tigris, Euphrates, the Indus, the Yangtze, the Yellow River in China. And that's not an accident. And it's really only in modern times that we've been able to grow our populations in regions where water supply is not that reliable, because we either built infrastructure to bring reliable water to those areas, or we import the food from places where we have enough water into those places where populations exist, but we don't have enough water to grow our own food or to do the things we want.
Yeah, and let's chat a little bit about that second age of water, because it corresponds with the exploding human population. What types of things changed? What did we do as humans differently during that era that have really led to the future or the present that we're in now?
Well, the second age of water really started in the Islamic Golden Age in the 900s, and the Renaissance in Europe. Some of the brilliant advances that came out of the early Chinese civilizations. When populations started to grow, when we outgrew our ability simply to take water out of the nearby rivers, we had to expand our ability to grow food. And so that led to the Green Revolution, which I argue in the book was as much a revolution of irrigation technology and our ability to find and pump groundwater to supplement those rivers, as it was a revolution of crop type or agricultural technology. We learned about water-related diseases and germ theory. We learned what caused water-related diseases, but we also learned and built the technology to address and solve water-related diseases that now provide most of us who are listening probably today to take water for granted. It allows us to turn on our taps in the morning and get incredibly high quality, incredibly cheap water, and not to think about it. Again, a sort of a remarkable advance in modern days. It permitted us to build big dams, not just little dams out of brick and mortar, but massive dams that produced hydroelectricity and really provided flood control and drought supplies during dry periods. So modern technology and modern society has really permitted us to manipulate the hydrologic cycle in a way to let modern society become what it is.
Yeah, and would you kind of view that as a overall period of exploitation?
There's an interesting contradiction here. It's both a period of time with remarkable benefits to us. Our society wouldn't be as successful. The planet wouldn't be as successful today if we had not learned how to manipulate the hydrologic cycle the way we did. But it, of course, brought these unintended consequences. It brought terrible impacts on ecosystems. It brought the failure to what I call water poverty in the book. Even though we know how to provide safe water and sanitation to everyone on the planet, we have failed to do so. There's still billions of people that don't have access to safe water and sanitation. It brought climate change, because climate change and the hydrologic cycle, of course, are intimately connected. They're part and parcel of the same thing. And now we have to deal with the consequences broadly of climate change, but specifically for water resources. It brought conflict over water. Growing populations, we've provided water and food for growing populations, but we've also produced an enormous increase in violent conflicts associated with water resources. So it's been a mixed bag.
Yeah, and I was really interested by the discussion of water poverty, that it's not so much a lack of water in any sense at all. It's simply a lack of, in a way, will, in order to sort of impose the technologies that we've well developed. We've had mass chlorination for over 100 years, and to deploy those technologies in the places that need them.
Yeah, so one of the basic characteristics of the hydrologic cycle that we all, of course, remember from second grade is that water is badly distributed around the planet. We have as much water today on Earth as we had 4 billion years ago, but we have wet areas and we have dry areas and we have dry seasons and we have wet seasons. It's that's the hydrologic cycle. Because of that, we have. Well, let me put it this way. Despite that, there's no region on the planet that doesn't have enough water to provide for basic human needs, the small amount of water that would be required for drinking, cleaning, sanitation, basic human needs. The much larger amounts of water for industrial goods and services, for agricultural production, that's a challenge. And because of that, we move food, we grow food in wet areas and we move it to dry areas, what we call virtual water transfers. But there is no place on the planet that we couldn't provide safe water and sanitation to everyone. We have the technology to do so. That's not a problem. We have the money to do so. It's not an economic problem. It's, as you say, and as I say in the book, it's a failure of commitment. It's a failure of will. It's a failure of governments to meet those basic human needs. And one of the consequences of the second age of water is ongoing massive water poverty.
Yeah, I mean, I was struck by the example that you used of the International Space Station, wherein obviously it's a location without a lot of water, but they're able to kind of through various techniques reuse water effectively and make do with very little. And it seems as though obviously those technologies would not be scalable, but there's quite a lot of good tech out there that could be deployed.
Yeah. So interestingly enough, I think those technologies, or maybe somewhat simpler versions, less expensive versions of the technologies, could be scaled to the entire planet. Water is very heavy. It's really, really expensive to launch into space.
Right.
And so we try not to. And we, of course, for much longer space missions that we're contemplating, traveling to Mars, traveling to the outer planets, we can't carry all of the water that's going to be required unless we're really, really good at reusing it, at recapturing it, of turning it into a really, truly closed system. And the truth is, the Earth is a closed system, too. It's just a really big one. And so we've developed remarkable technologies that we're testing and using on the International Space Station that pull water from the atmosphere and recirculate it, that takes water from wastes and recirculates it. And we recycle and reuse more than 95% of the water on the space station. And we still launch a little bit of water every now and then up there to replenish supply. But there's a remarkable recycling system up there that we could probably imitate much better here.
Yeah, absolutely. And let's chat more about that in a moment. But I wanted to jump back to, the ecological effects of, the way that water has been used and overused over the past, periods within the that second age of water. What types of effects are we seeing, or can we expect from this sort of water overdraft where we're using more water than we necessarily can for a long period of time?
Yeah, so that's a huge question. There are many complicated interacting pieces to that. Maybe the simplest way to start would be to say there are problems associated with the amount of water that we use and where we take it, sort of the water supply question. And there are problems associated with water quality, things we do to water resources that contaminate it, that change its quality. And all of those supply and quality questions have ecological impacts. Obviously, taking water out of rivers and drying up rivers destroys river systems and fisheries. Damming rivers totally changes the ecological structure of rivers, and we have dammed and overdrafted almost all of the big rivers around the world. We overpump groundwater, another supply problem, overdrafting groundwater and turning it really into a non-renewable resource. When you overdraft groundwater faster than nature recharges it, groundwater levels drop. Surface flows, which are connected to groundwater, dry up. Wetlands dry up. We contaminate a lot of our water resources. We dump our wastes into rivers and streams and lakes and the oceans, and there are ecological consequences of that. And then maybe actually a third category is associated broadly with land use. We fill in wetlands, we pave over marshes, we dry up the aquatic ecosystems that migratory birds require or that provide nutrients for rivers, for fisheries. So water quality, water quantity, changes in land use, they've all had massive impacts on aquatic ecosystems. As the book says, aquatic species are probably the most threatened species with extinction of all of the species on the planet. And that's a water problem.
Yeah, and I was struck by the fact that the amount of freshwater coverage on the planet is 1% or so, yet it contains so much of the biodiversity that we have around the globe. It seems like it's profoundly undervalued by some within our systems.
It is profoundly undervalued. That's a good way to put it. The value we gave to those systems in this second age of water as we were developing our water systems basically was zero.
Yeah.
Again, we didn't understand and we didn't care about the environment or the ecosystems because we didn't, we were focused on providing the water we needed. And yes, 97% of the water on the planet is salt water in the oceans, and 1% is the water in our rivers and the lakes, and then there's water locked up in the ice caps and glaciers. But freshwater biodiversity is, I forget the exact number, it might be half of all of the biodiversity in aquatic systems on the planet. It's incredibly important, and it's been incredibly abused.
And this is also, of course, a situation like so many others I talk about on this podcast that's going to be complicated, worsened, made more difficult by the effects of climate change.
Yeah, so I'm a climate scientist by training in part, climatologist and hydrologist. I did some very early work on the impacts of climate change for water resources, early modeling to try and understand how climate change would impact water systems. And the hydrologic cycle is the climate cycle. As we change the climate, we're changing, temperatures go up, evaporation rates go up. More water in the atmosphere means more intense rainfall events, although not evenly. And we're seeing more extreme dry and wet events around the world. We're seeing changes in sea level that affect coastal ecosystems, coastal groundwater systems, coastal freshwater marshes that are increasingly going to be contaminated with salt water. Climate change is a water problem as much as anything else. We have a saying in the climate world that if climate change is a shark, the water resources are the teeth, because that's really what's going to bite us, and that's where we're going to feel the pain. And we're already seeing changes in all of those aspects of the hydrologic cycle.
Okay, and in this conversation and within the book, I think there's a tendency to work our way towards a very dystopian and very difficult picture potentially of the future, where we sort of lined up all of these, stressors and impacts that are, contributing to a very difficult set of circumstances, to say the least. But I was struck by the book's not being a pessimistic tome. It's not a dire, dystopian outlook where, things are going to grow ever more hopeless. You describe the third age of water as one in which we have the opportunity to do things differently and solve some of these problems.
Yes, not only do we have the opportunity to do things differently, but I actually believe we will. I don't know when. It's going to be a slow process. I don't think we'll reach that sustainable, positive future in my lifetime, but I really think it's inevitable for a number of reasons. And again, not to discount the pain that we'll be experiencing between where we are today and where ultimately we want to get to. But I also see all around us positive examples of successful, sustainable water solutions that can be scaled up and that can move us toward that positive future. I argue in the book that we wouldn't choose that dystopian future if we had a choice.
Right.
And the point is we do. We have a choice. We can choose to understand and to do the science and to do the economic work and to do the social and institutional work necessary to solve these problems. We can grow more food with less water and improve the efficiency of water use. We can find sources of water that don't require draining rivers and lakes and aquifers and contaminating our ecosystems. We can restore rivers, and we're starting to take down dams. We've taken down 1,000 dams in the United States, mostly small, ecologically destructive, economically unproductive dams, but increasingly bigger and bigger ones. And we're showing that rivers can be restored. We're starting to be able to swim in rivers that, 10, 20, 30 years ago were cesspools. We just have to learn the lessons of what works and what's successful and scale them up as fast as we can.
Yeah, and what general areas, are those at which we might take some of those steps? Is it removing dams and paying attention to additional water resources? But what kinds of practical things should we be thinking about from policy standpoint, for instance?
I talk about something called the soft path for water, which is a comprehensive, overarching strategy for dealing with our water problems. The hard path was really the second age of water, the hard infrastructure we built, the hard institutions, centralized institutions that we built, ignoring ecosystems and thinking about water purely as an economic good rather than a human right. But the soft path for water says, let's use water more efficiently. Let's start thinking about the demand side of the equation and figure out how to do what we want with less water. And we're already doing that with better irrigation systems, with better toilets and washing machines. We produce semiconductors today with far less water than we did 20 or 30 years ago per dollar or per unit semiconductor. So improve efficiency is number one. The second is rethink supply. Supply of water is critical, and we have to think about new sources of water that don't require taking water out of ecosystems, and in particular, recycling and reusing wastewater like they do on the International Space Station. We collect wastewater. We have laws that try and protect our water quality by requiring us to collect and treat our wastewater, but typically we throw that water away. We can reuse that water, as we're doing in Singapore, as they're doing in Israel, as we're starting to do in California. That's a drought-proof source of supply. We can treat that water to incredibly high standards and reuse it. And that's part of the whole earth approach that we need. So rethinking supply is the second one. Understanding the importance of water for ecosystems is third, and restoring ecosystems, providing basic water for ecosystems as the first line of defense is again something we're moving toward, but we need much more of. And maybe the fourth category is rethinking our institutions. We manage energy over here, we manage water over here, and we manage food over here, and we sort of manage climate, or not really. But we need to manage those things together. And our institutions are not really designed for that. They're designed, we have 21st century technology and maybe 20th century politics, but we have 19th century institutions. We need to upgrade our institutions for a different world to manage in a more comprehensive, holistic fashion.
Yeah, and will that require, greater global collaboration? Because, obviously many of these issues are, cross-border in nature.
Yeah, so interestingly, water is of course an international issue, but it's also a very local issue. And so when I talk about institutions, part of it is we need different kinds of institutions for different scales of problem. Most of us deal with water just locally. We have local water districts. We get our water locally. We treat our water locally. But sometimes water crosses political borders, and water ought to be managed maybe at the watershed level and not at the political institutional level, and we don't really do that very well. Water crosses national borders, and we have conflicts over water that's shared internationally, and we ought to have better international organizations that reduce the risk of conflict over water. There are lots of scales to this problem, from the local to the international, and there are lots of scales of how we ought to react to them. There are individual things that some of us ought to be doing, and there are things that our local governments and states ought to be doing, and there are things that the international community ought to be doing. And it's sort of an all hands on deck kind of a problem.
Yeah, absolutely. One thing I feel obliged to just ask about, for those who kind of are thinking in a Samuel Coleridge, Rime of the Ancient Mariner kind of way, and eyeing that 97% of water on the globe that's, full of salt, how do you think desalination fits into this in a big way or no?
Yeah, water everywhere, nor any drop to drink.
Right.
Samuel Coleridge. That's a wonderful poem, actually. I recommend people go back and read or listen to the full poem. It's quite a dramatic example of the ability to suffer serious consequences from the lack of fresh water when you're still surrounded by water. In this case, when you're surrounded by the oceans. As I think I said earlier, 97% of the water on the planet is salt water. It's too salty to drink, too salty to use to grow crops, but we know how to take salt out of water. We know how to desalinate water, and we do in places where we're willing to spend the money. It's very, very expensive. It has ecological consequences that need to be addressed. I think of desalination sort of as the last resort after we're very efficient, after we're recycling and reusing our wastewater, after we've devoted the fresh water resources of our region to restoring ecosystems. Then we can desalinate water. We have to be willing to spend the money for the high valued uses, for drinking water, for industrial uses. I don't think it'll ever be cheap enough for agriculture, but there are other sources of water that we can use for agriculture. So I think of desalination as a component of our solutions, and I write about it in the book. But again, sort of a last alternative.
Yeah, certainly not the silver bullet. It's really going to take the combination of all of these other, elements and strategies together.
Exactly. It's not a silver bullet.
Excellent. Well, I would like to thank you very much for joining me today. I've really enjoyed our conversation, and I've learned quite a lot. And I, again, recommend for those readers who'd like to learn more to go ahead and check out that link in the show notes and get a copy of this book. It's a good one. Thank you.
Well, it's my pleasure. Thanks again for having me on.
And that concludes this episode of Bioscience Talks. Just a reminder, the journal Bioscience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.